Now that we understand where the coefficients come from, we're ready to state the binomial theorem. Let x and a be any real numbers. Then for any positive integer n, we have x plus a raised to the nth power expands to n choose 0, which remember is 1, and then x to the nth power. And then our next coefficient is n choose 1, which remember is n, and then you have a to the first power, x to the n minus 1 power, followed by n choose 2. Now a gets a second power, right? It's going up by 1, and x is going down by another 1. And our arbitrary term here, just any general term in the expansion, would be n choose j, a is raised to the jth power, and x is raised to the n minus j power. Remember, your exponents on a and x always must add to n, so j plus n minus j is n. And then we get down to our last terms where a is raised to almost nth power and x is raised to the first power. And our last number is here n choose n, and a is raised to the nth power. And we know n choose n is 1. And then the term before that, remember, should be n in front, and n choose n minus 1 is n. We can think of this arbitrary term in the middle of the sequence as representing any term in the sequence. And so if we're adding a bunch of these terms together, we can rewrite this in summation notation. We have the formula for finding each term of our sequence, and we're saying add from when j starts at 0 all the way until n, however many terms you have. Let's practice and expand the binomial x plus 5 raised to the 4th power. So x is the same as x here in our definition, a is 5 in this case, and n is 4. So our first term will be n choose 0 and then x to the 4th power. Then we'll have 4 choose 1 and then 5 to the first, x to the third. 4 choose 2, 5 to the second, x to the second. 4 choose 3, 5 to the third, x, and then 4 choose 4, 5 to the fourth. From here, we'll go ahead and just simplify each of these terms. Our final answer is x to the 4th plus 20x cubed plus 150x squared plus 500x plus 625. Let's see how the expansion changes when we change our binomial from x plus 5 to x minus 5. So the key here is to think of this still as an x plus binomial, but instead we're adding negative 5. So our a value from the definition becomes negative 5. So here's what our terms will look like. Our expanded answer is x to the 4th minus 20x cubed plus 150x squared minus 500x plus 625. So you notice almost everything is the same except for a couple minus signs. You can see that our first sign is a minus sign and then it alternates plus, minus, plus. Let's try expanding 3x plus 4 to the 3rd power. So keep in mind here that now 3x is behaving like x in our definition, and then 4 is our a, and then 3 is our n. Using the binomial theorem, we get our first coefficient to be 3 choose 0, and then 3x, which is behaving like our x, gets raised to the 3rd power. Our second coefficient will be 3 choose 1, and the 3x is now raised to the 2nd power, times 4, which is raised to the 1st power. And then our third coefficient will be 3 choose 2, 3x is raised to the 1st power, 4 gets raised to the 2nd power, and our final coefficient is 3 choose 3 times 4 to the 3rd power, and no 3x here because it would be 3x to the 0 power. So working to clean up each of those terms just a little bit, and then here one more step to finish simplifying completely. We get 27x cubed plus 108x squared plus 144x plus 64 as our expanded expression.